In this tutorial we will be building a low-poly kitchen cabinet in Blender, then publishing in Trinity. Let's start in Blender. Create a cube and give it the dimensions 60 by 60 by 60 centimeters. Move the registration point to the center of the lower back edge. Then move the unit to the origin. Remove the front face. We can use this to form a door later. Extrude the inner faces to give the cabinet some thickness. Export the model in GLB format, ready to be imported into Trinity. Now let's switch to the Trinity backend. Press Add Model to begin importing your newly created model. When a model is selected, a preview is shown. If this is the right model, press Upload. Selecting wall as the snap target will cause the object to snap to all walls. The stackable snap type means the unit will snap to other units, edge to edge. Choose a category for the model. Finally, choose a default material. The material key is the first 4 letters of all objects you want the material applied to. Choose a material from the material library. Check how your model looks in the preview window. When satisfied, save a thumbnail. Finally, save your model details. Congratulations! You have published your first simple model in Trinity. Let's go back to Blender and add a door. Hide the cabinet and unhide the face we previously saved to form a door. In edit mode, select the left lower vertex. Using Shift and S, move the 3D cursor to that point. Now we will create a snap point. A snap point is where the origin of one object will be attached to another object. Create a new empty object. Blender will create it at the current position of the 3D cursor. Name the empty object as shown. In Trinity, an object beginning with an underscore will be ignored for rendering. The initials AS stand for accessory snap point. Then comes the name of the snap, followed by another underscore and an identification number. Let's give the door some thickness by extruding the face. 2 centimeters should be fine for this example. Create a collection that includes the cabinet and the newly created snap point. Keeping things in collections makes life easier when exporting. Let's export the cabinet again, this time together with the snap point for the door. Now let's move the door to the origin before exporting that as well. Now we are ready to switch back to Trinity. Re-import the cabinet. Trinity will give a warning that an object of that name already exists. We want to overwrite the first model, so simply press Upload. And finally, the door object is uploaded as a separate entity. We should give it the snap target, door, as this is the name we used in our snap point on the cabinet. We can also apply a category and a default material before saving. In this case, the material key is also door. Remember to create a thumbnail. This will be used to display the product in all menus. We can choose to make the door a default accessory of the cabinet. This means that when a cabinet is added in the room planner, it will already have a door, although this door can be made switchable with other door styles. Let's quickly preview the cabinet in the room planner. When using dynamically applied materials, the same model can represent different products that share the same geometry, but different finishes. Let's create a copy of the first door, but give it another color. We can change its name and default material. Remember to save a thumbnail to easily identify the product in the accessory menu we will be building next. Let's create an accessory group called Cabinet Doors. We add our two newly created doors to the group. Now we can make our accessory group available in the configuration menu for the cabinet. Switching back to Blender, let's create another snap point, this time for a handle on the door. Just as before, we create an empty object and name it _AS, and then the name we want to use for the snap point. In this case, handle. Let's create another collection, just to keep things nice and tidy. Export, then re-import the object to Trinity. Both our doors are updated simultaneously. We already have an accessory group in the system containing a couple of handle examples. Let's add it to the cabinet's accessory groups. All models can be previewed in the Single Product Configurator window. So now we have a cabinet where we can switch doors and handles. Finally, we will create a JavaScript class for our cabinet model, so we can add custom controls. We open our project in Visual Studio Code. Navigate to the Classes folder. Here we add a new JavaScript file called cabinet. All 3D object types should extend the decor object. This class takes care of model loading, accessory placement, material application, as well as snap points. We start with the constructor function that invokes the superclass. The class should also include a class type property which is the same as the class name. Finally, the default export type should be stipulated. Remember to import the decor object class. The base class includes a function called onReady that is called when an object is finished loading. We can use this function to check that everything is set up correctly. Back in Trinity, we can choose the object's model class from a drop-down list. By loading the cabinet into the room planner, we can see that the function has been called. Now we can work on our class, adding whatever functionality we want. In this case, we want to provide a slider that opens and closes the door of the cabinet. Overriding the register properties function means that we can add our own properties. Trinity comes with a range of inbuilt UI components. Here we have added and configured a slider. But so far it doesn't do anything. The inbuilt UI components all call a setProperty function on the object. Here we catch the angle property and send it to a function that finds any available door and sets its angle. As the door is an accessory, we know that it will be placed on the accessory layer, a standard part of the decor object. In this case, we can look for an object with a snap type door. And there we have it. A cabinet featuring configurable door and handles, and an animation controlled via a slider. And all in under 15 minutes, including modeling, publishing and programming.